For Chapter 9, Day 10, we're going to talk about graphing inverse trig functions. Taking a quick look here at the comparison of y equals sine of x and y equals the inverse or arc sine of x, you can already see how they compare. Remember, when you're taking the inverse, all you're doing is switching x and y. You switch the x and y's, okay? Remember yesterday we talked about how in order to have an inverse, you can only look at a certain domain restriction. That's why we have the rest of it is dotted. So our domain restriction for sine of x is from negative pi over 2 to pi over 2, which means that the domain restriction for sine inverse is going to be this negative 1 to 1, where the y value is from negative pi over 2 to pi over 2. So for both of these, we are strictly looking at this. And actually, let's go ahead and white out the rest of this because we don't need this anymore. So that is not included in our graph. Okay, looks a little goofy, but that part not included in our graph. Same here. This, that is normally part of our sine of x, whether we graph it or not, when we're talking about the inverse sine, is not part of our graph. So there is our graph of the arc sine of x on the right side. We can see this again down here now. These are two graphs that, just like we did for sine and cosine of x and tangent of x, when we memorize those special points, you should know these special coordinates. So for sine of x, notice that we start at negative 1 comma pi over 2, negative 1 comma pi over 2, and we go through the origin at 0, 0, and then we come up at 1 comma pi over 2. So this is the base graph that you should know, and we're going to apply all of our transformations on that. The domain is obviously from negative 1 to 1, and the range is the domain of the sine function. Remember, when you switch the x and y, the domain of the sine function is going to be the range of the inverse, so from negative pi over 2 to pi over 2. For cosine, it's a little bit different. Not much, though. We start at negative 1 comma pi. We go down through not the origin, but 0 comma pi over 2. And then we meet at 1 comma 0. So notice how it's slightly shifted on the graph, where again you have those domain ranges. The last one is tangent, arctan. You're going to have asymptotes at y equals pi over 2 and y equals negative pi over 2, and you would be going through the origin. Okay, so you can know that parent function as well. If we take a look on the back, I've already kind of pre-drawn in these base functions just to make it go a little bit smoother and a little bit quicker, so you can fill these in as you go. But here's the base function. It's the cosine inverse of x right there, where again we're at negative 1 comma pi, and then 0 comma pi over 2, and then 1 comma 0. All you have to do is apply the transformation to these three coordinates right here. So right here we got those three coordinates. Remember, a negative out in front. This is going to be a reflection over the x-axis. It's a vertical reflection when it's a negative out in front. So all you're going to do is you're going to take this coordinate and you're going to reflect it over to the equal side on the other side. So that's at negative 1 comma negative pi. This one will reflect down to negative pi over 2 comma 0. No, 0 comma negative pi over 2. And then this one reflects upon itself. So then your final graph here would look something like this. So the purple there is your final graph. Okay. Again, this dotted one is dotted. It's a little bit thicker because I saved the PDF in advance, but you don't need that anymore. So the purple one is the negative cosine inverse of x. If we take a look at number 2, same concept. We already have the cosine inverse of x graph. This time we are reflecting, because it's on the inside negative, we're reflecting horizontally over the y-axis. So if we're reflecting about this, that's going that way. That one's going to stay there. This one's going that way. So this one we will reflect over here. This one we will reflect over here. This one's going to stay put. So here would be our final graph. Okay, And again, that black one, the dotted line that we already had, that was our base function. So you can leave it or you can erase it, but that's the main graph that we have. If we take a look at number 3, this time we got a couple reflections going on here. We got to reflect over both. Reflect over both. So you can just go either way. It doesn't matter which order you go. We're going to go down here. That's 1. Then we're going to go over here. That's 2. So that coordinate's going to go there. This one over here is going to go down here. And then horizontally, it's going to be the same. This one, if I reflect it upon itself, it's not going anywhere. But then if I move it over, it's over there. So we got a lot going on here. We moved everything a couple times. Let's go ahead and get rid of those. So now we can see the final response here, where we end up with something along the lines of this. Okay, so there's our new one there. Number 4, we're switching to our sine as our base function, except this time we have it moving right 1 unit, which is nice because these tick marks end up being 1 unit wide. So 2 spaces would be 1, right? Because this is 1 unit, this is -1. So we move every coordinate just 1 to the right. There we go. Connect them. And that blue one, there is our new inverse sine function. Again, you can leave the black dotted one, or if you want to erase it, you can white it out. I'm going to do it just for this one because, again, writing things out in advance made it a little bit thicker, but that's all right. Last 2 here. If we take a look at number 5, we're going to correct this a little bit because these are a little bit messy. Again, from writing it out in advance, they save a little bit thicker. But we're taking the base sine function, except this time, because it's negative on the outside, we're actually going down pi over 4 units. So if you recall, here's pi over 2, so this would be pi. If we're going down pi over 4 units, that's going to be not a full tick mark, but what's nice about this one is it actually works out where it's the 1 grid mark, not tick mark, because our tick marks are pi over 4 units, but the graph grid marks end up being pi over 4. So there's our new graph. Last one here. Be careful with it. Again, this one, we got to be careful because when we draw this out, remember you have to change the order, put this in standard form. So we have y equals negative arc sine. Switch the order and factor out a -1. So we have -1 parentheses x minus 2 plus pi over 2. So there's a lot going on here. We have a transformation for each part here. So what we're going to do is we're first going to reflect over both the x and y axis. So let's go ahead and do that. So we reflect this over the x, reflect it over the y, reflect this over the x, reflect this over the y. But what you notice, look at that, what you notice is after we do this reflection, we end up in the same spot. So the reflections don't actually make a difference in this case. But what do make a difference is we still need to go right 2 units and up pi over 2 units. So we're going to take each coordinate and move right 2 units. So that would be 2 tick marks, and then up pi over 2 units. So again, my apologies for this. This is pi over 2 from our base function. So we're going to go up 1 tick mark as well. So this one went over 2 units, up pi over 2 units. So that's the top right. We'll go over 2 units, up pi over 2 units. So we're there. And then over 2 and up 1, and we're there. So this right here is our final transformation for the negative arc sine of 2 minus x plus pi over 2. So the red one there is our final. Make sure you have the base functions down. Make sure you know what the base arc sine, arc cosine, arc tangent are, and then you can just apply the same transformations as we did for all of our normal trig functions as well. Go ahead and do the homework. If you have any questions, ask your teacher.